Catherine is attempting to model the high tide of a harbour on a certain day. A graph is drawn of the height h meters against the time t in hours shown below. The high tide is at 6:30 hours and the height of the water is 10.8 meters. At 0400 hours, the height of the water is 10.05. Catherine uses an equation of the curve h is equal to c minus a t minus b all squared to model the high tide. Find the values of b, c, and then show that a is 0.12. Using the model, predict the height of the water at 0945 hours. Low tide is found to be at 1854 and the height of the water at this time is 2.2. Explain why the above model is unsuitable to predict the low tide. Okay, so we want a max at 6.5, 10.8, and we know it passes through 4:10:05. Okay, we're using 6.5 because 6:30 hours. Okay, we need to make sure that we convert the 0.30 hours, 30 out of 60, into a decimal. Okay, we're going to model it using this completing the square form. So if it's a max, okay, C has to be 10.8 and the B would have to be 6.5. So 10.8 minus A times T minus 6.5 squared. This will give the max, because this the smallest value this could ever be is 0. Therefore 10.8 would be the max, and that would happen when T is equal to 6.5. At 4:10:05, we have 10:05 is equal to 10.8 minus A times 4 times 6.5 all squared, which gives me minus 0.75 is equal to A times minus 2.5 squared, which gives A is 0.75 over 6.25, which gives me 0.12 as required. So B is 6.5 and C is 10.5 and A is 0.12 as required. Right, using our model, so at T is equal to 0.945, notice 45 over 60 is 0.75, then T is 9.75, and therefore H will be equal to 10.8 minus 0.12 times 9.75 minus 6.5 squared, which will give me 9.5325 meters. At T is equal to 18.54, T will be equal to 54 over 60, which is 18.9. Okay, that if we now put that value into our model, 10.8 minus 0.12, 10.9 minus 6.5, that gives a negative answer, and we can't really have that, so the model is not possible, therefore the model is unsuitable for the low tide. The low tide was around 2 meters something. Okay, so then Catherine decided to refine our model and obtains the graph below in radians for the 24-hour period. The graph has a maximum point of 6.5, 10.8, and a minimum point of 18.9, 2.2. This graph is represented by the model H is equal to A cos B pi x plus C pi plus D. Find the values of A, B, C, and D. And then it says boats cannot enter the harbour if the height of water is less than 4 meters. Find between which times the boat cannot enter the harbour during this day, giving your answer to the nearest minute. Okay, so we got our model here. We know there's a maximum, so the maximum points here will be at 6.5, 10.8, and the minimum will be at 18.9, 2.2. Now A represents the amplitude of the cosine graph, so that'll be 10.8, so the highest y value, or the highest h value and the lowest h value, and subtract it, and then we take the halfway point, which give me 4.3. So this here has to be 4.3. It's called the amplitude. The D will give the axis of symmetry here. It's like moving the axis up. How far has the axis been moved up? Well, it's been moved up from the lowest value plus the amplitude, which is 6.5. So this is called the axis symmetry. So we've got A and D. Now finding B and C is a little bit more involved. If we look at the graph of the cosine measured in radians, it looks like that. You should know that graph. Okay, so for forming two equations, the maximum value happens at 0, 1. So the angle has to be 0. So we will put B pi 6.5 plus C pi equal to 0. And the minimum will happen when the angle is equal to pi. So B pi 18.9 plus C pi is equal to pi. So here we use 6.5 because that's when the high tide is, and this is when the low tide is. Okay, if we do 2 take away 1, that will eliminate C. So we're going to get 12.4 pi B is equal to pi. The pi's will cancel out, so you're going to get B is 1 over 12.4. Now, it would be nicer if you put that in your calculator using the fraction button. It will convert it to 5 over 62, which is a nicer value to use. So if we now substitute that value into equation 1, we're going to have 5 over 62 pi times 6.5 plus C pi is equal to 0. The pi's will cancel out again, and you get that C is minus 65 over 124. So my model becomes H is equal to 4.3 cos of 5 pi over 62t minus 65 pi over 124 plus 6.5, giving A 4.3, B 5 over 62, C minus 65 over 124, and D being 6.5 or 13 over 2. Right, so then we require, for part E, we need to find where our model is equal to 4. So solving this, first taking 6.5, we're going to get that this is now equal to minus 2.5, and then divided by 4.3, we're going to have that cos 5 pi by t minus 65 pi by 124 is equal to minus 25 over 43. Okay, this is a trig equation. So if we make sure we're in radiant mode, if we do cos to the minus 1 of 25 over 43 in radians, you get 0.9503. If you draw your South Asian Tennis Club, you want to know where cos is negative, that will be in the second and the third quadrants. Making our angle with the x-axis. Okay, that now means our angle, which is this bit, will be equal to pi minus 0.9503 or pi plus 0.503. And then if you add this and divide by this, you're going to get that t is going to be equal to 15.14 hours, or t will be equal to 22.651 hours. We want times. So if you do take away the 15 and put 0 and then multiply by 60, you're going to get 1509 hours. And then 22:33 hours from that one. So the time would have to be between 1509 and 22 hours and 39. And you should check this just look by looking at the original graph. So the original graph is back here somewhere. So it looks about right, doesn't it? Okay, so this has been a video to show you how to model using a cosine graph. I hope you've understood, and I thank you very much for watching.